Greetings, Honors Chem. We have our density activity where we're going to measure the density of some things and calculate the volume of others. So if you look at your lab printout, I've collected my materials here. I have a 50 milliliter graduated cylinder. I have a beaker with some water in it. I have my balance. I have three cylindrical objects. You can see them laying there, a silver, a brass colored one, and a dark gray. And of course I have my brain and a calculator. So let's get started. The lab says to observe the three objects, and so I have a dark gray cylinder that you saw before, and I'll show you what I wrote down on the lab in a second. But there's my gray cylinder. Here's a silver, kind of cold to the touch, but a little shiny. And then I have a brass colored cylinder that's dull, okay, kind of dull, but it's also cold to the touch, okay? And then the lab asks you, and so you guys can do this, and it may be hard to estimate which one might have the greatest mass, but you can kind of put a check mark on your own lab. What one of these guys do you think has the greatest volume? And then kind of, I know you can't really feel the mass of them, but which one do you think might have the greatest mass? And go ahead and record that on your lab, and I'll show you what I recorded. So I thought that the dark gray cylinder might have the greatest volume. And when I was kind of picking them up, even though the brass one was the smallest, it felt to me like it weighed a little bit more than the others. And so you can see that that's what I recorded, and we'll go on to the next step, which is basically we're going to try to measure the density of two of the objects. We're going to measure the density of the dark gray object, the density of the brass object. And we're going to do that by something called volume displacement. Now for density, we need to measure the mass of something and we need to measure its volume. And I'll show you how we're going to measure the volume, but measuring the mass is going to be pretty straightforward. We're just going to put those on the scale. So I'll tell you what, let's flip your lab paper over. I will start taking the data and then you can write it in. It says take the mass. So let's measure the mass of the brass cylinder first. Okay, you can write that down. 15.45 grams. Take the mass of the gray cylinder next. Wait for it to settle down. 15.01 grams. That's the dark gray cylinder. And for the silver cylinder, we're just going to take the mass on this. We won't estimate the volume, as you will see. We'll wait for our scale to 0. Okay, 15.34 grams for the silver. Now we're going to move on to the next part of the procedure where we determine the volume by volume displacement. Stay tuned. Looking at part C, volume determination, I used my beaker and I added about 25 milliliters of water to the 50 milliliter graduated cylinder. It doesn't have to be exact because I'm going to be doing the volume of the brass once I put that in, and I'll be subtracting the initial volume. So the initial volume just has to be, convenient if it's around the same amount. So you guys could actually read that. So you can see the volume that is up there. You can see the meniscus, and I have the graduated cylinder against a contrasting colored object, sort of a green sheet of paper. So you guys can actually estimate that volume of the initial volume of the brass, without the brass cylinder in there, just the initial volume of the water. Go ahead and take that measurement, and then I will add the brass cylinder to it. Drop the brass cylinder into the graduated cylinder. Let's see if I can back this up so you can see it down there. There's the brass cylinder. And now you see that because the cylinder is in there, the volume of water has increased. So go ahead and make your measurements on that. You can see the meniscus there. And you can make your measurement. Again, this is a 1 milliliter scale, so you should be reading to the 10th of a milliliter. Okay, take your volume measurement, and I'll come back with the dark gray cylinder's volume estimation. The dark gray cylinder, there's my initial volume. The dark gray cylinder is not in there, so that is my initial volume. So go ahead and record what you see. Again, there's the meniscus. And I'll go ahead and I'll drop the gray cylinder in and we'll get the change in volume there. You see there's the dark gray cylinder in the graduated cylinder. You see the top of it there. Go ahead, read your volume. And you can see where the meniscus is again. So do your estimation skills, brothers. You got this. So go ahead and record that as your final volume for the gray cylinder. And there you have it, guys. There's the data table that I came up with. Hopefully your initial and final volumes don't have to be that exact amount. You're going to use whatever numbers you guys came up with for those readings in your calculations down below. But as you can see, if density is the relationship of an object's mass to its volume, well, this is the volume of the brass, not these guys. You use these guys to figure out the volume of the brass. And so it's an object's mass over the object's volume. And that's what that elapsed volume is. That's what that final volume minus the initial volume gives you the volume of the item that was placed into the water. And gentlemen, that is how volume displacement works. Okay. Now, what about the silver cylinder? It says here you're going to calculate the volume. Well, here's the thing. The silver cylinder I know is made of aluminum. Okay. And I know the density of aluminum. You can see it down below on your lab. Actually, I can move this up. The density of aluminum, the accepted value is 2.998 grams per milliliter. So if I know the mass of the aluminum, you can still see it there, and I know the density, I can calculate the volume of the cylinder. I didn't have to measure it by volume displacement. Okay? And so go ahead. So that's it for this mini lab. So go ahead, fill in your calculations, and we'll scan this and turn it into Google Classroom like we always do, pretty much. And I will see you guys next class. All right, take care.